Very good evening. In this session, we'll see what is leaching and what are the types of leaching. Let's discuss about leaching in detail. Leaching is one of the process of concentration of ores. It is removing the impurities from the ores. Let me go for a small presentation now. Let's discuss the leaching and its types. Let's know first what is leaching first. Let us will take the ore, will dissolve it in a particular solvent and we'll make it react in an aqueous solution. That's what we do in leaching. The solubility of ore in a particular solvent and its reaction in aqueous solution is called by the name leaching. First, what we'll do is in this process of leaching, we'll crush the ore. We'll crush the ore completely and we will dissolve it in a particular solvent. When we dissolve it in a particular solvent, the metal ore present in it will be converted into a soluble salt or it will be converted to a complex. That is a coordination compound. That is, the impurity will be insoluble. The impurity will not form a complex, whereas the metal ore alone will form a soluble salt or it will form a complex. Right? Whereas the gang remains insoluble and it will remain at the bottom. Right? So this is what happens in all types of leaching. We convert the metal ore either into the soluble part or we convert it into a complex, that is a coordination compound. See, this is common to all types of leaching, right? Nearly we have 4 types of leaching. The 4 types of leaching are cyanide leaching, ammonia leaching, alkali leaching, and acid leaching. As the name indicates, in cyanide leaching, we will dissolve it in a solution that can produce cyanide ion. In ammonia leaching, we treat it with aqueous ammonia. And in alkali leaching, we dissolve it either in sodium hydroxide or we dissolve it in sodium carbonate. In acid leaching, we dissolve it in sulfuric acid. These are the 4 types of leaching. The principle is common to all the 4 types. Let's get into detail with the cyanide leaching first. See, the cyanide leaching will dissolve either gold or silver. Actually, the process will be called by the name macrothophorous cyanide process. Right? We'll take either the ore of gold or silver and will dissolve it in an aerated dilute solution of sodium cyanide. Aerated dilute. Dilute means it must contain a lot of water in it, right? Either sodium cyanide or potassium cyanide we can take. It must be able to produce cyanide ion. That's all. When I make it dissolve, it gives me a soluble complex. Whereas the gang present in it, maximum the gang is going to be aluminosilicate. That is going to be insoluble. Right? So what we do, we take the gold. That is maximum, it is going to be alluvial sand or gravel. That is going to be the main ore of gold. We'll dissolve it in sodium cyanide or potassium cyanide. We supply excess of air and we dilute the solution. It forms a complex of orocyanide, AuCN twice minus. Right? That is the ore alone. The ore alone gets dissolved in this potassium cyanide and it forms a soluble complex. Then we'll remove, or if oxygen, if any, will be removed from there and it is treated with zinc. This is the main part in it and this is called by the name cementation. So the soluble complex is treated with zinc. So we take zinc and we take the gold complex Right? Here, if we compare the reactivities of zinc and gold, zinc is going to be more reactive. Therefore, zinc easily displaces gold from the complex and it forms zincate ion along with gold. Thus, we have purified gold. Right? So this we have zinc alone. No, this step alone is called by the name cementation. Right? The first step, we make it react with cyanide, potassium cyanide or sodium cyanide. We'll make it form a soluble complex and it is made to react with zinc, where we get gold. Okay, since we leach the gold ore with the help of sodium cyanide, this leaching is referred to as cyanide bleaching. Okay, let's move on to the next type of leaching now. The next type of leaching is called by the name ammonia leaching. It is called with the name ammonia leaching. See, in this ammonia leaching, what we'll do is, well, first the crushed ores, that is the ore will be made of a lot of crumbs. It will be first crushed. The crushed ores of nickel, copper and cobalt. They'll be treated with ammonia, aqueous ammonia. Aqueous ammonia is nothing but ammonia plus water. It is going to give us ammonium hydroxide. So we take the crushed ores of nickel, copper and cobalt and they are treated with aqueous ammonia. Right? When I do this, again, as we saw in the earlier slide, it forms some soluble complexes like NH3 4 times 2 plus, CuNH3 4 times 2 plus. Right? Like that, it forms soluble complex. Right? It selectively leaches metals alone. It takes up the nickel, it takes up the copper, and it takes up the cobalt, and it forms complex. The complex will be soluble and the gang is left behind. Maximum, the gang will be either iron 3 oxide or iron 3 hydroxide. Such particles will be insoluble and they'll remain in the water. So the same principle is for ammonia leaching as too. Okay, let's go for the next leaching now. The next leaching is going to be something about alkali leaching. Right? As the name indicates, here we leach the ore with the help of sodium hydroxide. Therefore, it is referred to as alkali leaching. Alkali means either we can take sodium carbonate or we can go for sodium hydroxide. Both can be taken. Right? See, for example, again, we make it react with aqueous alkali. It will form a soluble complex. The gang will be insoluble. See, let's go for an example now. Suppose if I take bauxite. See, this bauxite, it is going to be the ore of aluminium. It is going to be the ore for aluminium. This ore of aluminium is usually impure. When taken from the earth, it is usually impure. It is made to react with sodium hydroxide at a temperature of 470 to 520 Kelvin at 50 degrees Celsius. It gives us sodium meta-aluminate. Again, it's a complex which is going to be soluble. This hot solution is decanted, cooled, and filtered. The impurities settle at the bottom. Right? So now the hot solution, now decanted, cooled, and diluted hot solution contains only sodium meta-aluminate, whose formula will be NaAlO2. Right? Now the solution is neutralized by passing carbon dioxide gas because I need pure alumina back. I don't want sodium meta-aluminate. I need only sodium aluminate. Therefore, again, the solution is neutralized by passing carbon dioxide. Again, the precipitate, I'll get alumina. That is purified form of bauxite will be called by the name alumina. It is filtered at around 1670 Kelvin and we get pure alumina. That is, we take bauxite. The first Al2O3 that is bauxite. We dissolve it in NaOH plus water. We get NaAlOH 4 times. Okay, this NaAlOH 4 times is neutralized with carbon dioxide. We get Al2O3 XH2O, which is going to be the purified form of bauxite. This purified form of bauxite is called by the name alumina. Right? Let's go for the last type of leaching now, which is called by the name acid leaching. Here, we take sulfite was like a galena, zinc blend, that is ZNS, PBS, and then we treat it with hot concentrated sulfuric acid, right? When we dissolve Zn plus H2SO4 plus O2, uses ZnSO4 plus 2S plus H2O. Zinc alone dissolves in sulfuric acid and gives zinc sulfate. Again, from that zinc sulfate, we'll be able to give zinc. That will go for the process of roasting or something, convert to oxide. That after that we'll have some series of steps. So this just refers to the concentration of force. So this is about leaching. This is about leaching. So for all the 4 types of leaching, we have the same principle. First, the ore is made to dissolve in a particular solvent. It gives us a soluble ore particles and insoluble gangue particles, right? Again, that soluble ore particles are made to react with another reactant to give us the pure ore. That's the technique behind all the 4 types of leaching. That is cyanide leaching, ammonia leaching, alkali leaching, and acid leaching. All right. So that's the end of the session. Thank you.